You ever notice that sometimes solving equations can get, well, clunky and ugly, and knowing what to do when gets really confusing, and sometimes trying to use inverse operations just gets you into a big bind? I'd like to show you a simpler way to solve equations just by reading them and identifying the thing you don't know and going from there. Now, I totally made this method up. I called it the box method, but it works because what we're doing is we're reading the math and we're addressing what the math means. So it's really powerful. Let's go ahead and take a look at our first example. I think you could probably figure this one out in your head if you just read it. You see, what people say a lot of the times is they just say 3x plus 2 equals 11, but man, that doesn't really ask a question. It really doesn't even address what algebra means. The word algebra, well, it means to restore or make complete, and we're missing the value of x. So I prefer to read it like this. 3 times what plus 2 is 11. So what we're going to do is I'm actually going to put a little bit of a mystery box over the thing I don't know. I know what 2 is. I know what 3 is, but it's being multiplied by something I don't know. So this whole term right here, I don't understand. So I don't know what that is, really. I don't know what x is, so I don't know what 3 times x is, but, well, I do know what plus 2 equals 11. Well, that has to be 9, right? This is just 9. Without doing any inverse operations, just reading and thinking, I know that this box has to be 9. So the box, again, is 3x. So 3 times what is 9? I could just figure that in my head, right? 3 times 3 is 9. Done. No problem. So x equals 3. And that is the right answer, because if I go back to my original equation, 3x plus 2 equals 11, x is 3. 3 times 3 is 9 plus 2, 11. Now let's look at a little bit uglier one right here. This one's, well, it's rational. It's 5 times what minus 1? That whole thing divided by 4 equals 1? That's so ugly. Oh, reading it doesn't really help, but here's what I do know. I know that I'm dividing some unknown value by 4, right? So let's put our mystery box in that unknown value right there. So when I look at this now, what divided by 4 equals 1? Well, isn't 4 divided by 4 1? So the box has to equal 4, right? Because if this was 4, then 4 divided by 4 is 1, and it's true. So remember what the box was. It was 5x minus 1. Now, just like last time, I don't know what 5 times x is because I don't know what x is. So, but what minus 1 is 4? Isn't 5 minus 1 4? Yeah, 5 minus 1 is 4. So the mystery box is 5x. So 5 times 1 is 5, so x equals 1. That's it. I'm done. Now, let's try one that's really, really ugly. I bet, I've been teaching Algebra 1 for a long, long time. I bet first semester Algebra 1, most students that saw this would probably just curl up in the corner and cry. They wouldn't try it at all. Well, if we use our box method, it's not so bad. See, I do know what 24 is, but it's being divided by something that is just unknown. I don't know what this number is. So I'm just going to go ahead and put a box over the whole thing. I don't know what any of that really means. So, done. Now, if I look at this, it's like, well, what minus 2 equals 4? I think that this box has to equal 6, right? Isn't 6 minus 2 4? Yeah, it is. So there we go. The mystery box equals 6. Well, this is still kind of confusing and ugly. I know what 24 is, and it's being divided by something. Divided by something that I don't know, so I'm just going to put the mystery box right there. 24 divided by what is 6? I think that's 4, right? That has to be 4. So x minus 3 equals 4? 7 minus 3 is 4. X equals 7. Now I could plug that back in right here and make sure it works. Let's see here. 7 minus 3 is 4. 4 goes into 24 6 times. 6 minus 2, 4. You see, when you're solving equations, you're actually using inverse operations. Even if you don't know you are. Inverse operations, well, that's the opposite of your normal order of operations, PEMDAS. We're using PEMDAS backwards. We're doing SADMAP. Kind of weird. Anyway, do you get the big idea? You take something you don't know and you cover it up with your mystery box. And then you just figure out everything else. Here's one, though, gets a little bit tricky because, well, you remember how just not 20 seconds ago I was talking about inverse operations and SADMAP and PEMDAS and all that right there? Well, we have to be careful right here because we could say that the only part we don't know is this. And we could then divide by 3, or add 2 to both sides first? Well, you see, when you're solving, you're doing order of operations backwards. So you're doing addition and subtraction first, and then you're doing multiplication and division. Then you're doing exponents, and then you're doing parentheses. Those all go last. The exponents and parentheses go last. So I'm going to do that first, and I'm going to do that second. Do you see what I mean? So let's go ahead and do this with our mystery box right here. We're going to go ahead and we're going to put the 3 as part of the unknown part. I'm going to put the mystery box over the whole thing. So that's actually a lot easier. It doesn't really matter what this thing is. I know that it's 2 more than 25. Do you see? Because if I subtract 2 from it, it equals 25. So this is 27. The mystery box has to equal 27. Now, the mystery box was 3 times the quantity x minus 2 squared. Oh man, now, I know that 3 is 3, and it's multiplying by something I don't know. It's really ugly. It's x minus 2 squared, but this is 3 times something that I don't know. The whole thing, even though it's squared and it's got some operation inside the parentheses, I just don't know what it is, so put a box on it. It's 3 times that ugly thing right there. Equals 27. I happen to know, you probably do too, 3 times 3 times 9, 27, right? Well, so then this has to equal 9, the mystery box. The mystery box again was x minus 2 squared. Do you see? This is just one number. It's grouped together. The parentheses group it together. It makes it one number. Whatever this number is, we don't know, but whatever x is, this number right here, it's 2 less than that. So what squared is 9? That's really what it says. So the mystery box has to equal 3. And remember, the mystery box is x minus 2. So what minus 2 is 3? I think that's 5, isn't it? Isn't it 5? 5 minus 2 is 3. There you go. So if we go back to our whole original problem, 5. Do you see this has to be 5 right here? 5 minus 2 is 3. 3 squared, right? 9. 9 times 3, 27. 27 times 2, 25. We are absolutely correct. Now this is probably a new method for you because, well, I just made it up with the box thing. I'm sure that other people have done it too, but I think it's really cool because it takes something that is really complicated and makes me want to apply steps and makes it just kind of more natural. All I gotta do is read it and think about it. Like right here, 2 to what power? This is an exponent. This means I'm multiplying 2 by itself a number of times, and then if I add 5 to that, I get 21. I'm actually not going to do this problem in this video. I want you to try it. And leave me your answer or any questions in the comments below. And I got one more for you right now. So if you want to write that one down, go ahead. I will discuss it in a future video, but right now, we're going to leave it for you. Here's the next one. It's almost the same exact question. But do you see, if you make this part the unknown, if you box this part out, it's the same question, you just have one more step when you're done. Alright, so to wrap up, what we're doing is we are reading the algebra very, very carefully. Algebra means to restore, to make whole, to find the part that is missing that would make the whole equation true, right? And then the parts that are unknown, the missing parts, well, we are putting a box over them to just make it simpler to look at and think about, right? And then we're just figuring out what that part that we boxed out means, and then we look at what the box was, and if there's something else we don't know, we box that out and keep going until we're done. So I have 2 questions for you. The first is, well, if you're solving an equation, how do you know when you're done? And the second question is, how do you know if you're right? Anyway, I hope this has been helpful. If it has been, click like, maybe subscribe, share it with your friends, visit my website, thebeardedmathman.com for, well, more information on solving equations. I will put a link in the description, and on my website you will find all kinds of help for you that will help you from all the way from Algebra 1 all the way through high school. And maybe you don't know, maybe you've heard me, maybe I sound like a broken record, but I'm doing all of these videos and all of this material is for free for students, parents, and teachers because, well, I want students to graduate from high school, and if they're going to go to college, I want them to jump right into high-level math or to test out of math that might be needed for their careers. I think it's really a shame that people get out of high school and then have to take remedial math in college, or almost worse, people avoid dream jobs because they're afraid of the math they would have to do in school. That's a shame. It doesn't need to be that way. It doesn't need to be that way at all. It's not the math's fault. It's the way that math is, well, it's the way that education has been just treating math. all procedural. I hope that you understand how to solve equations and what's involved with it. In the next video in this series, we're actually going to look at equations where there's more than one x, and sometimes you have to simplify first, and then you're using the order of operations. You're using PEMDAS. And then after you get done with that, then you have to use inverse operations. You have to use SIDEMET or the box method. Yeah, kind of tricky. Takes some experience. So anyway, once again, thank you very much for your time, and I hope you have a great day.